Crunchbase. But the majority of this talk, all of this talk is from a previous company that I just recently left. So since it's still early, let me tell you what this talk is going to be about. So if this is not what you expected, you can quickly jump into somewhere else. This is about testing Salt, specifically your customizations, meaning the Python code. This is not about testing SLS. This is not about bigger strategies. This is about testing the Python code that you've developed. This is not about unit testing Salt itself either, just unit testing your customizations. And this is all this is all done using the IMP module within Python. My slides will be posted. Fortunately, my name is relatively unique, so it is easy to Google me and find Twitter and LinkedIn and all the other social stuff. So if I don't see them, I will post these slides eventually. So what am I going to talk about? First, I'll give a quick intro. I will talk about some basic testing strategies that we used at my previous job. And then I'll talk about the IMP module really quick, a couple of examples, and then a summary. So why do you want to write tests? Hopefully this doesn't need a lot of explanation, but the goal is obviously to make safer changes. When I first joined my previous job, it was relatively small. It was about 20 people, and it grew to a little over 200 when I left. Obviously, this meant the team grew, both my direct team as well as development as a whole. So as you have new people come on board, you want them to be engaged as quickly as possible. If they can't make any changes until they understand all the complexities of all the systems and how everything interacts, it could be months or years before they can make any substantial change. So writing tests obviously allows them to have a fair amount of confidence in being able to deploy small stuff relatively quickly without, again, gaining this large knowledge base. Also, to extend that same idea, not just people on my direct team, but developers as a whole. And this is literally DevOps. The goal was to get developers as engaged with the infrastructure code as they were their own code. Obviously, there are a number of challenges with this, but that was the goal. There were a lot of developers where we didn't have our test coverage was not great, but it was better than zero. And so the areas where there was no test coverage, developers did not want to make any changes. And I'll talk a little bit about that in the end. So the background of this previous company, we had a small team. When I left, it was about 60 engineers and 3 infrastructure engineers to cover all of the code that we needed to deploy, manage, et cetera. We used several top files to do kind of overall orchestration. And these top files obviously have the normal high state. But then we had another one called Bootstrap, and this would bring the system up into a standard state. For example, users, adding any configurations in /etc, anything along those lines. And then we had another one called deploy.sls. How deploy.sls worked is it would take grains from each minion, figure out which applications were supposed to be running on that host, and then deploy as needed, whether it meant upgrade, install from scratch, remove, et cetera. This will become important when I talk about Dart launching. Next, everybody in my team had a dedicated Salt master that was completely isolated for them to test changes and to test new code. We used AWS. Specifically what this meant is we had a separate AWS account. So the chance of bleed over between even development and these testing boxes was almost zero. So some simple testing ideas. First, you can't get away from testing without talking about PRs and code review. If you're not doing code review, you need to. I developed all of the Salt at my previous company with some legacy stuff, and I submitted PRs to my team. Even though I was in charge of all of it, I knew how everything worked. It was important not just so that other people review. I made a lot of typos, usually in comments. It wasn't important just to review that. There's a side effect for code reviews, and that is knowledge sharing and involvement by the team. If you're the lead of the team and you're just doing whatever you feel like, the rest of your team doesn't necessarily feel engaged. So it's not just a technical piece. There are non-technical aspects to code review. Next is test equals true. If you don't know about this, this is very handy. You run your state. It'll show what should have happened if you would actually run the state. Next is show SLS, and we'll touch on this a little bit at the end. Essentially, if your state doesn't work and you don't know if it's a data problem or the actual state itself, show SLS will just show you that it was actually compiled or not. Separate environments, this is very standard. You have a prod environment, you have a staging environment, QA, maybe multiple different environments for a variety of reasons. Unfortunately, the term environment can mean a variety of different things. Salt has its definition of environments. You can extend environments into AWS, whether that means different VPCs or completely different accounts. There are multiple ways of calling environments. In this specific setup, we used environments at the AWS level. All of the Salt code was in one environment, was in base. We didn't use environments that way. We wanted to, we just never got to it. Dark launching, essentially you put something out there and, quote, nobody can see it. When I mentioned these multiple top files, this is where the dark launching became important. Since the majority of actions, not all, but the majority of actions were done through these top files, you could launch a new state file, even if it was more or less a copy. So I have this do something and do something test. And do something test is almost the exact same thing as do something with a couple of small changes. You can throw those changes out there. People on my team can then test them in production or in real life scenarios and see if they really work. There is a lot of complexity when you do this. This means you have to commit the code. You have to keep them up to date. What happens if there's a critical problem? Do something, you need to roll it out. Do something test is now deviated. And now do something, you want to get it into production for real, into the top file. So you need to make another git change. There's a bunch of complexity. I'm not saying this is a great thing, but this is another way to test. Then obviously CI systems. We used Circle, but Travis, Solano, Bamboo, there are a ton of them. You run the CI systems, most of them, I believe, all use containers, so your environment is relatively constrained. So you could run through all of your states. There are obvious problems with this. Things like testing AWS integrations. We used Salt Cloud a fair amount for good and bad, and we couldn't test that very well in these CI systems. Testing Python. Hopefully these all look familiar to you. Flake 8 is a simple PEP8 validator. Unit test is the basic framework which you write tests. Nose is an aggregator that figures out which tests to run. Mock is a way for you to essentially abstract out other things you might call, so your unit tests are nice and constrained. And then coverage. You have to have metrics. You don't know if you're doing better if you don't have any data. So coverage is a way, not the only way, a way to show that you're actually writing enough tests to cover all of the Python code you write. The big problem we had is then what do you do about the dunder methods? You have all these dunder methods. How do you abstract those out within your unit tests? And this is where the IMP module comes into play. The IMP module is the basis for how import works. So if you're using import, you're using IMP essentially by default. What this allowed us to do was load the Salt modules directly, and then using mock to mock out all of the dunder calls. If you look at the IMP documentation, they will talk about find module and load module. This didn't work for me. To be honest, this was a couple of years ago, and I don't remember why. I just know that I couldn't get it to work. If you've ever worked in a startup, you know that time is probably your most critical entity. And so managing your time is one of the most important things. Load source worked for me. You take this with a grain of salt, no pun intended. Your mileage might vary. Load source worked for us. So a quick overview of load source. You give it a string. This is just a name, an ID to attach to it, and then the actual location of your Python file. And then what it returns is essentially the compiled code. The testing setup for what I'm going to talk about here, all of this is checked into this GitHub repo. Again, the slides will be posted. My name is easy to find. I have a fair number of repos, but they're all forked from other stuff. So this isn't that hard to find if you don't want to write it down. There are two main Salt modules, two custom Salt modules I'm going to talk about, simple and then more. When I say simple, they're really, really simple, but the latter one has a call to Dunder Salt to show how we tested it. File layout, this is a quick overview. The first thing is, again, I mentioned the simple.py and more.py. As I mentioned earlier, we only had a single environment. Your miles might vary. Take this for what it's worth. So this is all just within base. There are a couple of examples, some other SLS files, just to show kind of Salt is running. And then the tests are a peer directory to the Salt file roots. Notice there are no pillars, there's no grains, there's no custom states, just the SLS files. So it's a very, very simple layout just to show this unit testing. Also, you notice that within tests, there is a subdirectory for modules. And just like if you write Python code, you can't just throw Python code in the subdirectory and have Python find it. You have to throw a dunder init into there in order for nose to find it, just like normal Python packages. Lastly, you'll see a common utils. I will explain this one when I talk about the more.py. So the simple module, this is literally as simple as it can get. So within simple.py, again, within file, Salt files, base, underscore modules, simple.py, foo method that returns foo. So how do we test that this actually worked? Relatively straightforward. If you've used unit tests before, this should all look very familiar. You write a class, starting with the name test, that's how nose finds it, that extends unit test case. There is a setup method, which I'll talk about in a second, and then your test foo. So the setup case. Setup is not a init. This is something that seems relatively obvious to me now. At the time, I couldn't wrap my head around it. What setup does is it runs every time you run a different test case. So the test cases are test underscore whatever. So in a normal situation, you would have dozens, hundreds of different test modules, methods below. So before each one runs, setup is run. This is different than init, obviously, which is run at object instantiation and not before each test. There is a pair to this called teardown, which lets you then destroy anything that you might have created. The obvious advantage here is now every test you can have a relatively high confidence that things will be set up the way you want it. In this module, or in this method, you'll see some boilerplate for setting up directories. None of that's all that important. What is important is the call to IMP. As I mentioned before, IMP loads source, string, and then location to the file. And then it returns a compiled object that I throw into an instance variable so I can use later in the tests. Now, what happens when you want something a little bit more complicated? If you're using Salt, hopefully you're cross-calling to all the other modules. This is one of the real powers of Salt. So you call dunder salt command.run. Again, very, very simple. Echo foo. It doesn't get much simpler than that. And you return the output. One thing you'll notice is at the bottom, you have dunder salt equals an empty dictionary. And this is there to appease Flake8. If you just add all of these dunder methods, Salt's loader obviously injects all these at runtime. But Flake8 doesn't know about what Salt is doing. So in order to appease Flake8, you throw these at the end. These have no impact on the code itself. At least we never saw it. If you have seen something that would affect this, let me know, because that would be interesting to know. So what we would often have is if name equals main, dunder salt equals empty dictionary, dunder grains equals empty dictionary, dunder pillar, et cetera, et cetera. Now, in order to make the testing easier, we actually changed the code. Instead of calling the dunder methods directly, we created a wrapper class that then abstracted out all the dunder calls. What this allowed was an easy set of mocks. We originally started doing mocking of each dunder method, each dunder variable directly, and this got a little bit messy. The wrapper object made things a little bit cleaner. I mentioned the common utils. It's small. It doesn't really matter. Most of this is this boilerplate I mentioned earlier. Notice this is init, not setup, because those are common through everything and they don't change. If you do change it, you'll probably want to move this code to setup instead. The reason why I didn't do that is because then you have to add super to your own setup, which I'll show you in a second, which I didn't want to do. So that's why this is there. Right, and then the other thing is at the bottom, you hopefully can see the load module. This abstracts out the location of all the modules and then the call to the IMP load source. This, again, just makes it simpler. The basic goal here is to reduce the friction for people to write tests. The easier you make it, the more likely it is they're going to write their own tests. So now, how do you test with mock? Just as in the other example, the first thing is you write a class that now extends the common utils-based test case, which is in itself an extension of the unit test case. So this is still an extension, but now we've pulled in all the common utils. When you have, I think when I left, we had on the order of 100 different test files. Putting that boilerplate into all the test files got really, really tedious, especially when you factor in it's not just modules, but grains, external pillars, wheels, tons of different things. It got really tedious repeating that over and over again. So, and then setup, as I mentioned before, the previous code, the base test class in common utils used init, not setup. If you do put things into setup because you want to destroy stuff, then don't forget to call super of the test more module. Next, we have the actual test command. One of the things you may notice that's different is the inclusion of a doc string. And the reason this is cool is with nose, when you do -- verbose, it will actually output the doc string instead of the name of the method. So if you run these, if you clone the repo or fork it or whatever, and you run the code, what you're going to see when you run it in -- verbose mode, nose -- verbose, the previous test is going to say something like, what was it? Test foo, simple test foo, true, 0, something like that. Whereas this one is also actually going to spell out all the words. This is very handy when you want to be a little bit more explicit in what your output from your test runs are. Next, you'll see mocks patch object. So if you've never used this before, this is relatively straightforward. The first argument is the code you want to patch. The next one is the thing you want to replace, which is a string, not an object. And the last one is the thing you want to replace the second thing with. So the first one is the result of the IMP load source. The second one is the salt wrapper class, the name of it, not the actual object. And the last one is the actual object that you want to replace it with, which is this. So just as in the wrapper, we create an instance variable where salt is equal to a dictionary with a single key, because that's the only thing we happen to call here, that then calls a static method. This really should be a static method, not a class method. With the star args, it actually, either one kind of works. This is a bit of semantics, but it probably should be a static method. This works for a lot more than just modules. We used it for custom grains. We used it for external pillars. We didn't have that many custom states, but it should work for that as well. The external pillars required a little bit more work, but it was very beneficial. Lastly, we also tested out data migrations. We had a bunch of data that was in grains that we wanted to move to pillars. Earlier I mentioned this deployed SLS top file that showed which hosts ran which applications. This isn't the most secure thing, because if you have to bring up a host in the right environment, but if you did, you could throw any application on there. So we were trying to migrate from grains to pillars. So in order to make sure that the grain set of data matched the pillar set of data, you have to compare them, and that's what we did in the unit tests. Some other tests we ran. We had a bunch of data files that were all YAML, because that's what the default of Salt is. So we had some simple tests that would just use the YAML module, load in the file, and just make sure it worked. It literally crawled the entire repo and looked for anything that was .yaml and just made sure it compiled, because that has to compile. Jinja presented some challenges. We got a little carried away with Jinja at one point, doing this migration from grains to pillars, and it got a little ugly. Essentially what we did is we had to bypass certain YAML files, but then anything that had Jinja was moved elsewhere, and that was all just skipped. Test SLS. One of the things we started doing, when I talked about the salt testing or testing in general, I mentioned show SLS. What this would do is it would look for all .SLS files, it would just run show SLS, make sure it compiled, and that meant at least it wasn't completely screwed up, and it just verified that things were at least okay. And then we have test data. As I just mentioned, the data migration, we were trying to move from essentially one format to another. We were trying to change the structure around. We're trying to move things out of a shared data into, a shared directory into somewhere else. And doing all these migrations, the data had to be in two places for a bunch of reasons. So what test data did is it verified that the data in all places, and the worst case was actually in 3 places. The exact same data was in 3 places. So this would just test that somebody made a change to one, remembered to change the other 2. This was extremely beneficial because even after 6 months later, I would completely forget that we still had this other one. I would make a change. This test would fail, and I'd remember, oh, right, we have to put it in this other spot as well. Lastly, when you write tests, don't forget to test the negative. How do you know that your code is actually working the way you want? Your unit tests, not your code. How do you know your tests are actually covering the way you want to? You have to write tests that expose bad data, expose SLS files. The show SLS example is a great example. There were bad SLS files that we had in the test directory, not in the main file routes, that had just bogus stuff in it. So what would happen is in the test SLS files, if it saw a bad test, it would raise an exception. So if we were probing that directory, anything in there should raise an exception. Hopefully that all makes sense. Just remember to test the negatives to make sure that you're actually testing the thing that you think you are. Some of the challenges we had. Testing pillars was a major pain in the butt. This is why we ended up we started moving most of our pillar data into external pillars. There were a couple of other reasons. I mentioned this moving of data around. It was because there was a bunch of things hard-coded in pillars. Essentially things like if machine name equals, minion ID equals foo, then load this specific set of pillars. Stuff like that was all over the place. So in trying to fix that and to make testing easier, we moved most of our pillars into external pillars. So then it's just Python code. Multiple environments. The boilerplate I kind of glossed over. In a piece of it, there was essentially the file path was salt files base underscore modules and then whatever name you pass in. If you have multiple environments, that doesn't work. For us, this wasn't a problem because we had a single environment. If you do that, keep in mind you are wrapping up a lot of complexity in there. What happens when you make a change in, say, let's suppose you just have 2. You have base, which is prod, and you have dev. You just want to keep those 2 separate. And you might want to make a change to one module. So you make a change in dev. Now do you fork the unit test so that it only tests dev, the new dev code, or do you try and test both at the same time? There is additional complexity when you have to do that. In our case, we were lucky because we didn't. Having multiple environments would have been nice. This was not the gating factor for why we didn't have environments, salt environments. But it is something that does introduce more complexity into your unit tests. I mentioned testing the negative. Getting enough test data that exposed all of the edge cases, this was something that took some time. Keep in mind that you don't have to do everything great right from the beginning. If you have no unit tests today, just adding a simple framework is a big step in the right direction. And the same way with these bad data sets. Continuing to iterate over time and adding more and more that's something, again, you can do over time. You don't have to do right away. Cross-training, one of the goals I mentioned at the outset was getting other developers involved. Getting developers to actually make changes to the SALT code, which controlled all of our deployments. So if they made a major change to their application, they needed to change how the deployment worked, they would often send the ticket to somebody on my team. We would prioritize it, blah, 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 blah. It would have been far better for everybody if they could have just submitted a PR. However, that means they have to understand how SALT works. This proved to be a pretty substantial problem. Keep in mind that developers, they have product managers, they have other goals. There are lots of other things that are weighing on their time, just as things are weighing on your time. So the cross-training was a problem. The unit test as a whole makes that a little bit easier because they can make changes and feel more confident that there will be a unit test that will catch if they make a very bad change. Jinja, I already touched on this a little bit. Testing Jinja was a major pain. We did do a little bit of testing. I mentioned that we tried pulling the Jinja out of the little bit of YAML, the data YAML that we had. And we put it in a specific spot. We had another test case that would load the Jinja classes package and then try and compile it. Yeah, Jinja was a pain. Lastly, somebody submits 3 lines of changes. Do you ask them to write a unit test? That's a hard one. If it's 30 lines of code, that's a little bit easier. Where do you draw the line? What happens when the 3 lines turns into, well, we'll just add 1 more, I'll add 5 more, I'll add 10 more. So that's another hard one, especially when you don't have a framework. So building up the framework, as I mentioned earlier, to reduce friction and make it easier, makes this less of a discussion. If you don't have a framework, you have nothing for them to start with. They have to build everything from scratch. And you look at all the mocking and the wrapping that we did, this can prove to be a lot of work for 3 lines of code. Some random comments. I mentioned load source worked for us, but if you look at documentation, they talk about find module, load module way at the top. Those might be the preferred ways of doing it. Load source worked for us. Your mileage might vary. Nose has been deprecated. Keep in mind that a lot of this work has been going on for multiple years. Nose has been deprecated in favor of Nose 2. You probably shouldn't use Nose. It's been frozen. Nobody's working on it. You should use Nose 2. We tried and we ran into some problems. I don't remember what they were, but this is a normal problem, right? When you have a package that is no longer maintained, you do have to keep up with it. The Salt wrapper thing is cool, but it does add some overhead. How much? I have no idea. It should be relatively light. We had other performance problems and we had other bigger issues that were much more important. Figuring out the performance problems of our SALT module, figuring out the performance impact of these changes to SALT modules was nowhere near the top of our list. However, if you do this in spades and everything is custom modules, custom states, custom external pillars, you might want to look at the performance impact of adding these wrapping classes. Other testing platforms, Test Infra, it looks cool. I haven't played with it. Kitchen Salt, they mentioned a lot this morning, which was funny because I just added this last night. That also looks very cool. I just spoke to somebody. Again, this has been going over multiple years. When I started, Salt's loader couldn't do what I wanted. Apparently, that's all been fixed. So maybe you don't have to do all this work anymore to do the injection of the dunder methods. Somebody has told me that the loader can do this, but I literally found out about that like an hour ago. So I have no idea. Summary. So the goal of this, the goal of testing is to provide safer changes to a growing team, which may not include your team, which doesn't necessarily have all the knowledge that you want them to have about SALT, about the complexity of your infrastructure, how deployments work, the timing of deployments, et cetera. Testing involves multiple pieces. What I've talked about here is just unit testing your Python customizations. Dark launching provides another feature. Multiple environments provides another feature. There are multiple avenues for testing. And a combination of all of them can provide, again, a safer environment for your developers to make more frequent changes and to even to experiment a little bit if they're not sure if something works, if they have multiple ways, multiple hoops to jump through before it would affect production. That makes them feel a lot more confident that they can make these changes. And that is it. Are there any questions? And yes, Crunchbase is hiring. Yes?
How did you go about running all of your unit tests regularly? You mentioned that your CI platform, you could use the new CI platform, but what was your process there?
Yep. So the question is, how did we actually run the unit tests? We use Circle. So we had all the unit test plugins to Circle. The specifics are all of our Salt code was in one repo. This included the file roots. This included the pillar data minus security secrets. Those were stored elsewhere. And then any other data specific to Salt, including the tests. And it was all in one repo. We added that to our circle.yaml file, and so Circle ran it. Any other questions? Yep.
Did you ever consider testing the output of show SLS to test Jinja?
The question is, did we ever consider testing the output of show SLS? Yes, we thought about that. Just getting the show SLS, I quickly glossed over the fact that we started doing that. We didn't actually do it for everything. We started down that path. That turned out to be a little bit more complicated. The SLS might change in a really subtle way, and having to change the test every time you change an SLS proved to be a little cumbersome. So no, we didn't end up doing that. But yeah, we did talk about not specific show SLS, but the output of, I'm going to get these mixed up, low state. One of the lower level things that then feed show SLS. Yeah, we did think about that. Any other questions? Well, I'll be here for the rest of the conference, so if you see me, you have a question, just ping me. Again, my name is really easy to Google, so you can ping me on LinkedIn or Twitter or whatever. All right, thank you.